Okay, guys, we are on our fourth mini session. We're looking at this page of sample questions to study for your final. The question is, write out the sample space for the following experiment. Flip one coin and roll one four-sided die. So we're flipping one coin, so that could be heads. And we're rolling one-sided one die, so maybe you get heads and a one. You have heads and a two, heads and a three, heads and a four. Those are all the possibilities with heads. Of course, you could have also flipped to tails. Tails and a one, tails and a two, tails and a three, tails and a four. And that's the answer to that question. That's our sample space. Usually you'd use the sample space to then answer probability questions. So here's our question. Find the probability of getting a tails and rolling either a two or lower. So I would just find those in the sample space. Here's a tails of a two, and here's a tails of a one, which is lower than a two, and that's it. That happened 2 times out of 1, 2, 3, 4, 5, 6, 7, 8 times. So 2 out of 8, you can call that 1 out of 4. Next question. Find the odds of getting a heads and rolling an even number. So let's find how many of those are. How many are heads with an even number? So there's a heads with a 2, there's a heads with a 4, and that's it. That just happened 2 times. Now, how did odds work? Odds is a little bit different than probability. I'm not going to go 2 out of 8 on this one. That would not be right. Odds is how many times did it happen compared to how many times did it not happen. And so out of the 8, twice we had heads and an even number. So how many times did it not happen? 1, 2, 3, 4, 5, 6, 6 times. So my odds is a 2 to 6. And of course you can reduce that also. That reduces to 1 to 3. Next question. How many different cheeseburgers are possible if you have 3 types of buns, 4 types of cheese, 2 types of burger patties? Assume each burger only gets 1 slice of cheese. So what am I asking you to do here? This was our multiplication principle, we called it. If you have 3 types of buns, and then for each choice, there's 4 cheeses, and you start drawing a little branching tree diagram. The shortcut to this was 3 times 4 times 2. 3 types of buns, 4 types of cheese, 2 types of patties. So that's going to be 24. That wasn't too bad. Next question here, number 14 on my list. An ice cream store has 18 ice cream flavors. I'm going to get a cone with 3 different flavors. How many different cones are possible? So we're choosing 3 out of 18 flavors. And the question is, does order matter or not? So let's pretend order matters. So putting the chocolate on top is a different cone than if you were to have the same 3 flavors with chocolate on the bottom. When order matters, was that P or was that C? Which one did order matter for? Permutations or combinations? So order mattered with the P. Order does not matter with the C. So you're going to do 18 P3 on your calculator. On this calculator, it's under math, probability. I'm going to want to type what, the 18 first though. So 18 permutation, and then I'm going to click 3. Well, that's a lot. 4,860 and 96 flavors. 4,896. Last thing we're doing today, how many different cones are possible if order does not matter? So when order does not matter, we're going to go with the C, the combination. So this would be 18C3. And so I would try this on a calculator, 18C3. And when order does not matter, there's fewer, you could say overall there's fewer types of cones you're getting because you're counting those different combinations. It's kind of like the same cone. 816 for that. Okay, we're going to stop our review there, and then next video we will finish up our final review. Thank you, guys.